Today we'll be talking about nuclear chemistry. So first off, we have three types of radioactive decay. Radioactive decay. So first off, we have what's called alpha particle emission. Alpha particle emission. So we can also write what an alpha particle is. An alpha particle we can denote with the Greek symbol alpha, or helium with 4 neutrons and protons together and 2 protons. Or we can also write it as an alpha particle with the numbers 4 and 2. So, what's an example of alpha particle emission? So in this case, keep in mind that emission is going to mean that it's emitting. It is one of the products of this reaction, or one of the products of this decay will be an alpha particle. One of the products. So it's going to be on so-and-so quote, the right side. So one example is when we have uranium-238. So uranium has 92 protons, and uranium-238 has 238 neutrons and protons total together. When we say that it emits an alpha particle, we say that it's going to yield an alpha particle here, and we're going to use He, although we could use this or this. Any of these three ways are fine. But we'll stick with the first one, plus, and now we have to make the numbers of protons on the right side, namely this, and whatever is going to be here, equal the number of protons on the left side. And we have to make the number of protons and neutrons on the left side equal the number of protons and neutrons on the right side. So in order to do so, we can subtract 238 minus 4 will give us 234. So our number here is 234. And we take 92 minus 2 equals 90. So we have that the numbers on the right side will add up to equal the corresponding numbers on the left side. So when we look at our atomic table of the elements, what element has 90 protons? That's thorium. The second type of radioactive decay that we have is called beta emission. Beta emission. And once again, in this case, realize that emission means that it's giving off something. The decay is giving off something. We can denote beta emission with the Greek symbol beta, or 0, -1e. So in other words, what we have is, in this decay, is a neutron of the reactant element is converted into a proton. And so one of the products that is given off is an electron, which has an electron. Electron. And if we take a look, we realize that an electron has basically no mass compared to protons or neutrons, so we denote it as 0. And an electron does have a charge, but has a -1 charge, so it's sort of like the opposite of a proton. Is one way you can think about it, although that's not how it actually works. Okay, so now let's have an example. We have carbon-14. Carbon-14 is a beta emitter. So carbon-14, we know that it has 6 protons while looking at the periodic table. Carbon-14 means it has 14 neutrons and protons. And when we say, okay, it emits an electron, or we could alternatively write beta, what else do we have? What else does it turn into? Well, once again, we want to make sure that the numbers on the bottom row and on the top row, the numbers on the bottom row equals the numbers on the bottom row on the right. On the product side, the numbers on the top row on the reactant side have to equal the numbers on the top row of the product side. So we take 14 minus 0, that's still 14. But if we take 6 minus -1, we basically have to add 1 to 6. So we have 14 and 7. And when we check the numbers on the right, 14 plus 0 is 14. -1 plus 7 is still 6. So which element has 7 protons? Nitrogen. So we find that when carbon-14 emits a beta particle, then we get nitrogen. Now, our third way of radioactive decay, we're not actually going to talk much about the details, but it's called gamma radiation. Gamma radiation. And so in this case, we denote with the Greek letter gamma. But what we have to note is that it's not emitting any particle. Gamma isn't a particle. Gamma doesn't have a mass, so no mass. It has no charge. But it does have a lot of energy. So much so that it can penetrate through almost anything and can only be stopped by lead or concrete. So these are our 3 types of radioactive decay. Okay, so let's do a quick overview. There are 3 types of radioactive decay. First off, we have alpha particle emission. Secondly, beta particle. And thirdly, we have gamma. And an alpha particle is basically helium atom with 2 protons, 4 protons and neutrons. Beta particle is just an electron that's being emitted. And gamma has a lot of energy. And for alpha and beta particles, we always, if this is our reactants to our products, the alpha particle and beta particle will always be on the product side because they're being emitted. So these 2 are emissions. And this is radiation. So it's giving off a lot of energy. So that's a quick overview of 3 types of radioactive decay.